Okay, so the downloaded files of the website, they are actually processed by the Scrapy Spider itself, and the way they are processed is that the Scrapy Spider creates files with key value pairs. Okay, it contains for the text files, it simply contains the text content, and for the HTML files, it contains the text content as well as the raw content. Okay. Now, along with these two, it contains these keys as well: URL path, HTML title, raw content, and text content. Obviously, raw content and text content is something that I've already explained. But the difference between the raw content and text content is, if it's a HTML file, it contains both, right? The raw content is just the file dump of the HTML file. The text content is the text which actually comprises, which is actually present in the raw content. Okay, this is applicable for a HTML file. But if you were to download a text file, it does not contain text file. It does not contain raw content, because there is no such thing as a raw content for a text file. It contains only text, right? I hope you're understanding what I'm saying. So the HTML file contains all the JavaScript declarations, HTML markup, and body tags, and div tags, span tags, so on and so forth. And in between and inside of these tags, in between these tags rather, you have all the text that is visible and that can be gotten from the HTML file. But at the same time, we also are interested in knowing the raw HTML that has been downloaded by scraping. Okay. So for a given HTML file, you will have these you'll have both raw content as well as the text content keys. Okay, along with the values. The values are basically the raw HTML file and the processed text. Okay. When I say the processed text, it's basically you simply get the text content from the Beautiful Soup. Using Beautiful Soup, you get the text content from the HTML file. That's the only thing. And remember, there is no such thing as raw content for the text file. Okay, it only contains text content. Okay, fine. So so you keep reading these files. You keep reading the files, and then once you go inside the file, you are actually checking for these markers: text content marker, raw content marker, and um, basically these are the keys. Okay, these are the keys, and the corresponding values will be different for every file, obviously, right? So you have text content, raw content, and then you will have URL path, HTML title, and so on and so forth. So once you get across these things, okay, once you are actually going through the file, and then when you see these when you see the lines starting with these names, then it means that you are supposed to be reading the content of the uh, value. Okay, these are the keys, and you have to read the values, by the way. So you get the plain text. Once you get the plain text, basically what happens is, if you look at the text, if you come across the text content key inside the file, you keep adding the lines that follow this tag, that follow this keyword. Okay, inside the file, you keep adding the files, and then you keep adding the lines rather. The lines are basically text lines. Okay, you add them to the plain text variable. Similarly, if you see uh, raw content, whatever lines that follow this word, then whatever lines that follow this word, you keep adding those lines to raw HTML variable. Okay, basically raw HTML and plain text are string variables. Okay, and similarly, the moment you see URL path, okay, you take the You take the URL path using string split and all of that. You use that, and then you get the URL. Same goes for title. Okay, title is obviously present in the HTML file. There won't be any title for the text files, mind you. Text files are simply that. Okay, they're just that. They're simply text files. They don't contain any kind of markup. Okay. We do make sure that, okay, whether the downloaded file is this a text file or is this a HTML file, and we put this information inside Cassandra, I mean MongoDB. Okay, so once we download once we have this text and the raw HTML, we strip the extra spaces, leading and trailing spaces, and then we get the Sherlock model. We create a Sherlock object. We create an object for the Sherlock model, and then we add a new session for the project. What do you mean by adding a new session for the project? So basically, every time Sherlock Checker runs, it's a session for a given project. I told you earlier that there could be many sessions for a given project. Each session will have the crawling data for that particular time of the day. In case of Sherlock Checker, if I showed you the cron tab, right? So every 5 minutes we have a new session. Okay, and if it's a website that frequently changes, if it's an extremely dynamic website, for example, a news website is there, so news keeps coming, and there is a breaking news, then there is a lot of news from the other parts of the world. So it's a dynamic site, and the content keeps changing, and if you want to keep a tab on this particular thing, then you have to increase the frequency with which we get the data, right? So um, as and when a Sherlock Checker runs, it becomes a session for the project. There could be many sessions for the project, and obviously for every session we get the data from the website. So we create a new session for the project, um, and we get a SID. SID is the session ID. A session ID is used to uniquely stamp the data which is gotten for that particular session. Okay, this is also used to diff between two sessions of a given website, of a given crawl run rather. In the Sherlock main menu, you have already seen how to diff between two sessions of a given project. In fact, there is a menu choice that you can use to diff between two sessions of a project. Okay, so this actually helps us a lot to differentiate and to determine when the content has changed for a website. Okay, a session ID always has a timestamp as well, obviously, right? So you want to know when the site has changed, when exactly it has changed. So each session ID also has a timestamp. Okay. Also, we have a file type here which actually serves a useful purpose. It has a useful purpose because um, uh, as of now we are downloading HTML files from the TXT files, but maybe in future we may download other types of files as well, like for example PDF files, doc files, and Excel files, and so on and so forth. So um, the file type is a column in the project meta info table. We also get the size of the file in terms of text content. We are not interested in if there has been any change in the JS content, JavaScript content, or CSS content. It could be changing always, right? But the text content is what we are interested in. Has somebody added any new text in the web page? So this gives us a very good overview of a given website, and if there is any data that has changed, then you will immediately know, and the file size obviously increases, right? So I told you about the raw content and the text content. Text files do not contain raw content, and HTML files contain both raw content and the text content. So is raw content present is a boolean value that we check whether this is a text file or a HTML file. Mind you, this is just a start for Sherlock. This seems pretty simple way of differentiating whether it's a text file or HTML file, because these are the only two file types that we are interested in right now. Okay, so later on we may have to look at some sophisticated ways to differentiate the file type and to what kind of file this particular content belongs to, and that kind of a thing. Get tags is it's an interesting method. So basically, what happens is and mind you, this particular method is common to both HTML files as well as text files. Okay, because at the end of the day, we are interested in finding out the keywords and content that has been changed, right? So we actually send out, we may actually call the get tags method with the plain text that has been gotten from the downloaded file, and we get a list of tags. Okay, I told you earlier that tags are script driven, Sherlock driven. You don't have any say on creating the tags. It creates the tags by itself. Labels are something that you have absolute control over. You can label the downloaded files or the downloaded content in whichever way you want, in whichever way it makes sense to you. So labels are human driven, tags are program driven. Okay, and by the way, you can search both labels as well as tags. Okay, in fact, you can do global search. You can just enter a string and you can search for everything, project names, site names, tag names, nodes, and so on and so forth. So you're not missing out on anything. Okay. Okay. So add new session for the project actually creates a session for a project, which is entirely different from adding a session page for the given website. A session page is uh, crawled. It's a crawled content. It's a crawled content of a given page of a given website. Okay. So session for project is at the project level. Okay, and it contains uniquely identifiable session ID that you can use to differentiate different runs of a Sherlock, scrapey rather. And session page belongs to the page that has been downloaded from a given website. So there could be hundreds and thousands of session pages, right? Because a given website can contain hundreds and thousands of web pages. Similarly, this is just for one website, but what if there are 3 or 4 websites? Okay, it could be having um, it could be having multiple session pages, right? Multiple session, in fact, hundreds and hundreds of session pages. Fine. So we that's what we do. We create a session page and we put all the raw HTML, plain text, tags, URL, file type, file size, and SID. Okay. Get tags is actually a very simple method, even though it sounds very interesting. That's because of NLTK. This method actually becomes a lot easier for us to explain. Stop words are words which are pretty common in English language. For example, a, and, the, of, them, us, you, me. These are stop words. These are the words that we are not interested in. We are interested in the unique keywords. Every language contains stop words. In fact, search engines strip out strip out the stop words so that they can do the search on the actual keywords. Okay, that way you get meaningful results. Imagine if you were to search for the word D, right? D is the most commonly used article, right? So um, there could be millions, trillions of web pages that you would be getting. In fact, no search engine in this world can do such kind of thing, right? So we remove all these stop keywords and we just get, I wouldn't say stop keywords rather, I would say stop words. So we remove all these stop words and we get the list of keywords, unique keywords that comprise the downloaded text. Okay, so stop words we get it from the NLTK. Okay, and what we do is we get the plain text and we convert the plain text to all lowercase, and then we split it in such a way that we get a list of words from all the sentences, paragraphs, and everything. So we get a huge list depending upon how big the plain text is, right? So we are basically tokenizing. That's the right word for to describe what we are doing. What we are doing. So we are tokenizing this entire text, and we are getting a word list. Okay. Then what we do is we check whether this word list, whether the words are present, the words that comprise the word list, are they present in the stop list? Okay. So that's what we do. We check whether they comprise the stop list or not. If they are not, then that's fine. We add them to the database. So what we do is we basically strip the leading and trailing spaces, and then what we do is we check whether we have a valid word or is it a space. Okay, there could be a space, and then we would be unnecessarily adding the space as well, right? So we don't do that. So we check whether the word has a valid word is valid. If it's not valid, then we continue. We also make sure that we get a word which is of at least 3 letters. Okay, so we remove all the common English words like this. There could be a possibility that we might actually leave out abbreviations and other words that we might be interested in. For example, it could be a name of a person, like for example, Eli or Eli could be a name of a person, right? So there's a good chance that we might actually leave out such valid occurrences, but we have to think about how do we address that problem. Okay, but for the time being, we are removing all the words which are less than which are less than 3 characters. Okay, so by the way, I just gave you an example. That's not what we are doing right now. Eli is a word which will be actually which which we will actually consider to be part of the keywords of the words that we are interested in. Anything which is less than 3 is something that we discard. Okay. So here we check whether the word is part of the stop list or not. Okay. If it is part of the stop list, we do not uh, add that word to the database. Okay. So we do all these things for all the words in the word list, and then we return the non-stop words. Okay, stop words are ones which we don't consider, but non-stop words are obviously we are interested in, right? So fine. So we do that, and then we finally we add the session page here, which is what I've explained earlier. Let me go and explain the Scrapy Spider. Mind you, the Scrapy Spider is also part of the Sherlock util. Okay, if for example, if Sherlock util does not have I'm sorry, if you're installing the Sherlock for the very first time, you will not have a template for the spider. So we actually create the template as well, and we create the template file so that you can insert the words that you are interested in. For example, project names and site names and site URLs and all of that. So this is where we create the this is the method which actually creates the template. Okay, so there is no difference between this file and the text that you see here. I have kept this file for your reference. It is available from the top level directory, and you do not have to go searching for Sherlock core and then Sherlock util and then finally the method that which actually creates the spider template. Okay, so um, you can see here that these are the placeholders basically. Okay, dollar bank. The dollar bank is the are the um, um, markers, so to speak, to for the um, placeholders. Spider name happens to be a placeholder. Placeholder domains happens to be a placeholder. Okay, holder. Okay, uh, start URLs and so on and so forth. I would say these are the only placeholders that represent. Yeah, in fact, they are the only ones that represent. So don't worry about the placeholder stuff. It is pretty easy. Almost every templating language. We are using PyroTemp here, but every templating language has its own way of inserting the data for the placeholders. Okay. So what we do is SJSQ Spider is, in fact, I was lucky to finally hit the jackpot to create the spider. I was trying to see which website to use to actually crawl, which has lots of links and deep linking, and I was trying out various combinations, and then I created a Stanford spider, Berkeley spider, and finally SJSU spider seems to be working. I've tried a lot of other approaches as well, but fine. This is how the spider actually works. The name is actually the name of the project. Allowed domains is the list of the project. The allowed domains is the name of the website. Start URLs is the top level website URL. Okay, and the HTML link extractor. This is specific to Scrapy, by the way. If you know how Scrapy works, this should be easy to you. Um, Tim directory, get OS current working directory, dir name, downloaded data. Downloaded data is where we keep all the files that have been downloaded. Some logging statements. Basic config. We are using a basic config, logging basic config. Diff parse item is invoked by Scrapy, and what happens is we check whether um, um, we check whether the downloaded file is a text file or a HTML file, okay, plain text or HTML file. Looking at the content type headers, we will immediately know what kind of file that we have downloaded. So URL path, response URL. These are basically a list of bunch of things that we do. And once the file gets downloaded, we actually create a new file. And then that new file has a bunch of key value pairs. For example, URL title, URL path, HTML title, raw content, and text content. I told you earlier, text content is different from raw content. But in case of plain text files, there won't be any raw content. Okay, but just to keep to avoid um, having null values, we simply put plain text as a value for the raw content when the file that is downloaded is a text file. Okay, logging info. Okay, I'm sorry, but anyways, we can still go ahead and explain the rest of the files. Um, Rest of the file. Logging info has response body. Response body, I mean, if you can see here, when the file that has been downloaded is a HTML file, the logging info is different from when the file that is downloaded is a text file, because text file does not contain any markup. Okay, so that's why we put everything, I mean, whatever info that we have gotten from the text file, we put that using response body. Okay, similarly we do the same thing for logging info. Okay, and mind you, this is not important. Okay, logging all this information is not important. Okay, it does not affect the way how Scrapy works or Sherlock works. You can as well remove all the logging information. The moment you see logging.info in a Scrapy spider, you can just remove that. The reason I put all these things here is, I just wanted to debug all the debug the program while it is running and making sure that it helps. And at the same time, it also helps you to understand what kind of information is being downloaded, rather than going into MongoDB always and trying to find out what information has been downloaded and all that. If you were to change any file, and if you were to change something in the spider, you can always do so, and you can immediately know whether it has affected the downloaded content. Okay, so that's how things work for Scrapy Spider. Okay, in the final part of the video, I'm going to explain. I'm going to demo. I'm going to demo one run of Scrapy, one run of Sherlock rather, on Starrett Law, and I'll show you the kind of words that we have downloaded, the tags that we have created out of the downloaded content. The downloaded content itself can be shown to you. And before I leave, I would like to explain a few things here. For example, the line on which the cursor is sitting right now, it's a very important line. The reason I put it over there is UTF, Unicode, right? So this Unicode poses a major problem when we are downloading the files. We keep on getting, keep on getting errors that ASCII value is not present here. We cannot encode this value to ASCII and things like that. So I made a wild assumption that you would probably be interested in the English language, English web, rather than French or Spanish files, or French files, or French sites, or Spanish sites, right? So if you think that we should be global, or we should be able to scroll other sites in languages other than English, then please do so. I would be happy to make make Sherlock UTF-8 enabled. Okay, so for now, this video will conclude, and I'm going to start another video in which I'm going to explain the working of Sherlock Content Inspector and Sherlock Checker. Okay, bye for now.